This section is going to apply a lot of the information that we've done in previous sections to functions that have higher powers than just 2. Functions that have degrees of 3 and 4 and perhaps even higher than that. We don't know exactly how to graph those just yet, and quite frankly, to get accurate graphs, you're going to need some calculus, which is a couple of years down the road. So we're going to be using graphing calculators or Desmos in order to graph these and then analyze the graphs. So as you're watching this video, if you do have another device that you can graph on, I would strongly encourage you to do so you can follow along of what we're doing. The first example says we are going to determine the consecutive integer values of x between which each real zero of f of x equals x to the fourth minus 2x cubed minus x squared plus 1 is located, then draw the graph. First off, what does it mean to find the zeros of a function? The zeros of a function are the values of x that, when set equal to 0, what you get for solutions. On a graph, the zeros of a function are located at the x-intercepts. So we are going to graph this function on a graphing calculator, and then we're going to see where it crosses the x-axis, and those are the zeros of the function. One of the things I do want you aware of is that since we are using a graphing calculator for this, the directions of this example, as well as the directions in your assignment, it says to determine the consecutive integer values of x. This is for if you were to graph this using just a table, but we're not going to use tables. We're just going to plug this into a graphing calculator. So instead of finding the consecutive integer values of x, we're actually going to use the x-intercepts that Desmos or graphing calculator shows us, and we're going to write the answers in terms of decimals. So the first thing I need to do is we are going to graph that function. So I've already typed in the function, and again, to find the zeros of the function, we're going to look at the x-intercepts, and so let me highlight the x-intercepts, and you can see that it's not going to be a whole number answer. These are just estimates. So we're going to have an x-intercept of positive 0.72126 and an x-intercept of 2.34859. So there is the important part of that graph. So our answers are going to be, and I'm not going to write out the whole thing there. I'm just going to write out to the hundredths place. So our zeros are going to be located at about 0.72. And we have a second zero located at about 2.3. And if I round properly, that 8 is a 5 or bigger, so I should round the 4 up to a 5. One of the things to remember is that to find the zeros, we're only looking at the x value. You really should not write the whole ordered pair. You're just writing the x values because it's just the x values at the x-intercepts that are the zeros of the function. Let's do another example. This one is f of x equals 2x to the fourth plus x to the third minus 3x squared minus 2. So let's put that one into a graphing calculator. And there's that graph. And we can see it also crosses in just 2 places. Let me highlight those. Crosses there at about negative 1.64 and about 1.238. Which, if I were to round that to the nearest hundredth, since the 8 is 5 or bigger, I should round that up to 1.24. So my x values should be negative 1.64 and about 1.24 if, again, rounding to the nearest hundredth. Example 2 has this it says use a table to graph f of x equals x cubed plus x squared minus 5x minus 2. Estimate the x-coordinates at which the relative maximum and relative minima occur. Relative maximum and relative minima are types of extrema, and recall that extrema are the high points and the low points on a graph. So again, it did say use a table, but we're not going to do that. We are going to use Desmos again. So we will go back to Desmos and we will graph that function. There's that function. And if I highlight the relative minimums and relative maximums, I can click right there. You can see there's one of the relative maximums. And then down here is the relative minimum, the low point. So to answer the question, estimate the x-coordinates at which the relative maximum and the relative minimum occur. I'm only going to identify the x-coordinates. So on the left side, you can see that there is a relative maximum, and at x equals, and that is negative 1.66667. So I suppose I could round that to just negative 1.67, but that's actually an exact fraction. That's actually negative 5/3, if you remember anything about what negative 5/3 looks like. And then down at the bottom of the screen, we have a relative minimum. That is a low point on the graph. And the relative minimum is there at an x value of 1. Let's do the next one. We're going to graph f of x equals negative x to the fourth minus x to the third plus 5x squared plus x minus 3. So again, let's graph that one. And there's that graph. And with a leading coefficient of negative 1 and an even degree, it's a degree of 4, we should be decreasing forever to the left and to the right. So this is probably all of the relative maximums and minimums that we're going to see. So if you don't think it is, you can just kind of scroll down a little bit. You can see that it just continues to go down forever and ever. So I think we're pretty safe. So let's go ahead and highlight the maximums and minimums. So we have a high point there. So there's a maximum. And got to be really careful. It looks like there are two critical points that are really close to each other. You can see right there, they got two gray dots that are kind of blending in. But that one right there is actually the relative minimum. And then there is a relative maximum at that point. So to answer the question, what are the x values of all the extrema? We have two relative maximums. Again, we have a relative maximum here and here. So those are the x values for that. So relative maximums will be at x equals about, I'm just going to call that negative 1.96. And also a relative maximum at x equals about negative 1.31. Excuse me, that's positive 1.31. And then there is a single relative minimum. And that is at the bottom of the hill right here, circled in blue. And that is a relative minimum of x equals about negative 0.097. Blow that up a little bit so you can see it. So since that's a 7, I have to round the 909 up to a 10, so negative 0.10.